Hello and welcome everyone. In this day 38 learning, we are going to be looking at resolution. In the last day learning, day 37, we looked at hashing basics and a simple hash function which can be used to hash and store values of numbers and strings. So we also came across collisions in either the numerical type hash values or a key type hash values. So a specific key can have multiple indexes of the can need a same index. So there a collision might occur, but there are different collision resolution techniques. So first thing is direct chaining. Direct chaining. So under this there is separate chaining. So we will talk on this one. And open addressing, here we have linear probing, quadratic probing, quadratic hashing, and double hashing. So these are the four key techniques. So in case of separate chaining, let's take an example. So let's take an example 80, 41, 22, 44, 59, 32, 31, and 73. So we should already be able to identify or tell there are collisions at these two indexes, that is 1 and 1. So what happens is we can create an list array of values like 41 and 31 at index 1, index 1, creating a list of values that are required to be stored at index 1, or we can even have a um, linked list which points to the next value like this, right? And this can be null. So either array or linked list or linked list. So this can happen, right? So that's a simple way of uh, collision resolution with separate chaining, where we uh, if we see a collision at an index, then we simply create an array of items or a linked list, right? So let me switch to JSPin and let's see the code example for this. Okay, so here I've written few definitions and the different types of collision resolutions that we have. And separate chaining, each bucket is a list of entries, right? So it is obviously simple to implement, but uh, easy deletion performance degrades gracefully, because as more elements are stored at a specific index, the list or the linked list keeps growing in size. And only thing is, the extra linked list at a specific index keeps growing very large, and searching at a specific index which is of large, again, increases time complexity. So that's the only drawback, but it's the simplest one to implement, right? So implement and also to understand, basically. So insertion at a specific index, if we hash this index, we get a specific value, and we have a buckets, and if it's existing, then uh, insert it, else if the bucket at the specific index is already having a value, then we say that there is a collision, then we push such objects to it, right? So key and a value, right? So that's about it. this is a simple insertion method. I also have few other things like a search function here, a delete and other things. This should be easy to understand. I will not discuss too much on these, but yeah, insertion is where we will be focusing on. And this was about sub chaining hash table or separate chaining method, right? So we will look at the next one. I will even run this here. If you see, we have these values here, and so here we have these values here. So we already know that collisions occur at 3 and 23. So 18. Okay, this one. 18, 21. Okay, so collision at 22 because uh, 22 and 32 because there is already a value at 20. So inserted 32 into bucket 2, right? So once we display this, so bucket 2 will have two items, key of 22, value of 3, and similarly uh, 32, value of 6 at this value, right? 0, 1, 2, 3, 4, 5, 6. So and also 82 here. So that's the whole idea of separate chaining. Okay, so let's switch to drawing board and let's understand the other open addressing techniques that we have. Second technique is open addressing. Under this we have linear probing. So linear probing or hashing. So the whole idea in linear probing is, let's say we have an example. Let's take an example of what we had here. So I had taken an example. So let's consider this as an example where I had 3, 13, 23, 4, 58, 88, 78, 8, 28, and 38. So these were the 10 different values that we have. So so let's say these are the 10 different values, and let me have a table size of 10, table of 10. So let's take 1, 2, 3, 4, 9. So let's take this, and okay, so here we know that 3 can be stored in index of 3, while 13 um, is already having a collision with 3, since 13 modulus of 10 will give us 3 at index 3. There is already a collision, there is collision. So we check for next open index. So what we do is 13 plus I modulus of 10. So 13 plus 1, 14. So 13 can go here. Similarly, 23 is conflicting with the index 3 and also 4, so we move to the next open index. While 4 is seen, 4, which should have been here, is already occupied by 13, so we move to 5 again, that's occupied, so we move to the next open index. So finding the next open index is what will happen. So 58 can go here, 88 goes here, next open index, 78 goes to here, and the way that 88 comes to here is 88 plus uh, 88 should have been here, so it would be increased by plus 1, which is 89. 89 is open, so 89 can be considered here. Similarly, 78 plus 1 is occupied, 79, so 79 uh, gets to 80 modulus of 10 bucket size will give us 0, which is an empty index, so this goes here. Similarly here, this goes to 11 and this goes here, and lastly this is 28 here, and 38 eventually moves to here because all the other values are filled. So that's about linear probing, where there are uh, collisions. The next open index in a table is searched or is put into, right? So the way that search function works here is we start out at an index and we see if the specific value is empty. So that's the key idea. So let me switch to JSPin and let's look at the um, code implementation. So here is the insert method. So first we start out with an index and steps 0. If it's not empty, then we start increasing the step size and also the index plus 1 and the total size of the table. So as long as the step size doesn't overflow out of the table size, we keep increasing it, else we say that the hash table is full, right? So that's an error that we throw out. So yeah, that's about uh, insertion start. The key idea is we take the number of values that we get uh, carefully, like table size should be picked based on the array input, right? So let's say we have 10 values to be hashed, so it is self-sufficient to have 10 as a table size or bucket size and increase from there if we need more open space, right? So the one disadvantage in linear probing is, so there is clustering of values and it is always densely clustered. Like for example, a 3 is here and 13 gets here and 4 gets here. So uh, once there is a collision, the next value starts moving to the next open space only. So we have quadratic probing or quadratic hashing, which will slightly improve the clustering or move the values little um, to the far index positions, like quadratic quadratic probing. So let's say 3 is there. So we have a table size of 10. Still take a table size of 10. So 3 can 0, 1, 2, 3, 4, 5. 6, 7, 8, 9. So let's consider these values. So 3 can obviously go here. So once 13 is there, so we see 13 is already having a collision. So we increase it by I square. So in this case, let's say we increase it by 1 and modulus of 10. I square plus 10. So this goes to 14. So the next open index. Once we see 23, which again has a collision here, and let's take another value of 33 here. So let's say 23 is there. So we see I at 0 initial index, which is 3, is already filled. So we try the next available index 23 plus 1 square, which is 24, which is already filled again. So we increase it to 2 square. So 2 square leads to 427. So it goes here. So next we see 4, 4 which is for 4 which is already having a collision. So we increase it by 1 square, which gives us 5, 5. So here it can be. So 33, 33 again will have a collision here. I square again gives a collision. I to the power uh, 3 power 3, which is 9. 9 which leads to 42, and this would be here. So that's the way that quadratic probing works. So there would be a lot more spacing around a collision value of the same index, like 3, 3, 3, right? So that's the whole idea. Let me switch to JSPin and let's quickly understand the code implementation for this. In case of quadratic probing, here we have the insert method. As you can see, step size is multiplied by 2, right? It is like I square. So again, we throw the error once we are exceeding the table size or the bucket size that we look to hash and place it in the specific table, right? So that's the whole idea. So now it's about double hashing. So in double hashing, so we previously what we were doing in linear or quadratic hashing was we were either increasing uh, hash of a key plus 1 or I square in quadratic hashing. In case of double hashing, we do it this way: hash of a key plus I into I into uh, first prime number minus key modulus of prime number. This is the second hash function, second part. So these two will give us the final hash value, which again can be mod by key, right? So let's take an example. So let's say let me see what example I have in my JSPin editor. So let's take 3, 13, 23, and 4. 3, 13, 23, and 4. So in double hashing, like let's take a table size of 10. Table size of 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is 3, which goes here, and 13, which gives us 3 initial hash 1. In case of hash 2, so it will be 7 and 7 minus 23, 13 by 13 modulus of 7. 13 modulus of 7, which is 9 here, right? And this would give us 2. And this would be put here. While 23, 3 and 23 minus 23 divided by 7. So this would give 2. This would give 7 3s are 21, and this would be 2, and 2 21. 21 mod will be 1. This will be 1. 3 plus 1, which is 4. This is for 23. This is, and similarly for 4, 4 is already occupied here, so 4 is the hash 1. So in case of hash 2, 4 modulus of 4 by 7, which is equals to 3. 3 1, and 4 minus 1, which is 3 again, so 3. So we need to double hash it, right? So here if you see, we can multiply it by 1 times. So this entire result gives 1. So 1 into 2, so this takes up 3 minus 2, which is equals to 1. So in case of 1, we do not have anything, so 4 gets into the index of 1. So that's the way that double hashing works. Okay, so I see one major mistake that I did in hashing of 13, 23, and 4. So in case of 13, it would be 3 hash of 1. So it goes here, that's 13 module of 3 is equals to 3. This is hash 1. In case of hash 2, it would be 7 minus 13 of 7, which gives this is 6. 7 minus 6, which is equals to 1. So this gives out 4. So this should be here. So this is for hash of 13, while for 23, hash 1 is equals to 3, hash 2 is equals to 7 minus 23 modulus of 7, which is equals to 2. This will be 2, and 7 minus 2, which is equals to 5, and this will be equal to 8. So 23 will be at 8th index. So that's the whole idea. And with 4, so with 4, I will cancel all of these out. With 4, we know that 4 will have 4 h1, and h2 will be equal to 4 minus 4 modulus of 7. 4 modulus of 7, 4 minus 4, um, 7 minus 7 minus 4, which is equals to 3, and this will be equals to 7. So it will be at 7 as 4 plus 3, which is equals to 7. So 4 should be here. So that's the whole idea. So it will be h1 plus h2, right? So okay, so understanding this, we into I. So h1 is nothing but key modulus of table size. h2 is equals to prime number minus the key modulus of prime number. Okay, so this is the whole idea. Let me move to the JS bin. I think this was little tricky, but good to understand it in a simple way. I hope I made this understanding quite easy. Okay, so with insert function in double hashing, I have few methods here. Prime number below the number, specific number, a simple hash function, which is just a hash function 1, and second hash, which is calculation of prime number and this value were the key modulus of prime, and we add it based on the base index, that is the hash 1, and I times the second hash, right? And the entire thing modulus by size. So that's the whole idea. And we firstly check if base index is available in the table, then we are good to insert it, else we say that there is a collision, and then we start finding a new index with double hashing method. So that's about the insert method. I hope you can go through all these function with the code link that I paste with the GitHub link that I paste in the video description. I will stop this video for now. Please do post any comments or doubts that you have to discuss. I will be happy to look into comment section and discuss there. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.